ancient Greeks had a great idea. The universe is simple. In their minds, all you needed to make it were 4 elements: earth, air, fire, and water. As theories go, it's a beautiful one. It has simplicity and elegance. It says that by combining the 4 basic elements in different ways, you can produce all the wonderful diversity of the universe. Earth and fire, for example, give you things that are dry. Air and water, things that are wet. But as theories go, it had a problem. It didn't predict anything that could be measured. And measurement is the basis of experimental science. Worse still, the theory was wrong. But the Greeks were great scientists of the mind, and in the 5th century BC, Leucippus of Miletus came up with one of the most enduring scientific ideas ever. Everything we see is made up of tiny, indivisible bits of stuff called atoms. This theory is simple and elegant, and it has the advantage over the earth, air, fire and water theory of being right. Centuries of scientific thought and experimentation have established that the real elements, things like hydrogen, carbon and iron, can be broken down into atoms. In Leucippus's theory, the atom is the smallest indivisible bit of stuff that's still recognizable as hydrogen, carbon or iron. The only thing wrong with Leucippus's idea is that atoms are, in fact, divisible. Furthermore, his atoms idea turns out to explain just a small part of what the universe is made of. What appears to be the ordinary stuff of the universe is in fact quite rare. Leucippus's atoms, and the things they're made of, actually make up only about 5% of what we know to be there. Physicists know the rest of the universe, 95% of it, as the dark universe, made of dark matter and dark energy. How do we know this? Well, we know because we look at things and we see them. That might seem rather simplistic, but it's actually quite profound. All the stuff that's made of atoms is visible. Light bounces off it and we can see it. When we look out into space, we see stars and galaxies. Some of them, like the one we live in, with beautiful spiral shapes spinning gracefully through space. When scientists first measured the motion of groups of galaxies in the 1930s and weighed the amount of matter they contained, they were in for a surprise. They found that there's not enough visible stuff in those groups to hold them together. Later measurements of individual galaxies confirmed this puzzling result. There's simply not enough visible stuff in galaxies to provide enough gravity to hold them together. From what we can see, they ought to fly apart, but they don't. So there must be stuff there that we can't see. We call that stuff dark matter. The best evidence for dark matter today comes from measurements of something called the cosmic microwave background, the afterglow of the Big Bang. But that's another story. All of the evidence we have says that dark matter is there and accounts for much of the stuff in those beautiful spiral galaxies that fill the heavens. So where does that leave us? We've long known that the heavens do not revolve around us, and that we're residents of a fairly ordinary planet orbiting a fairly ordinary star in a spiral arm of a fairly ordinary galaxy. The discovery of dark matter took us one step further away from the centre of things. It told us that the stuff we're made of is only a small fraction of what makes up the universe. But there was more to come. Early this century, scientists studying the outer reaches of the universe confirmed that not only is everything moving apart from everything else, as you'd expect in a universe that began in a hot, dense Big Bang, but that the universe's expansion also seems to be accelerating. What's that about? Either there's some kind of energy pushing this acceleration, just like you provide energy to accelerate a car, or gravity does not behave exactly as we think. Most scientists think it's the former, that there's some kind of energy driving the acceleration, and they've called it dark energy. Today's best measurements allow us to work out just how much of the universe is dark. It looks as if dark energy makes up about 68% of the universe, and dark matter about 27%, leaving just 5% for us, and everything else we can actually see. So what's the dark stuff made of? We don't know, but there's one theory called supersymmetry that could explain some of it. Supersymmetry, or SUSY for short, predicts a whole range of new particles, some of which could make up the dark matter. If we found evidence for SUSY, we could go from understanding 5% of our universe, the things we can actually see, to around a third. Not bad for a day's work. Dark energy will probably be harder to understand, but there are some speculative theories out there that might point the way. Among them are theories that go back to that first great idea of the ancient Greeks, the idea that we began with several minutes ago, the idea that the universe must be simple. These theories predict that there is just a single element from which all the universe's wonderful diversity stems, a vibrating string. The idea is that all the particles we know today are just different harmonics on the string. Unfortunately, string theories today are as yet untestable, but with so much of the universe waiting to be explored, the stakes are high. Does all this make you feel small? It shouldn't. Instead, you should marvel in the fact that, as far as we know, you are a member of the only species in the universe able even to begin to grasp its wonders, and you're living at the right time to see our understanding explode.